Welcome everyone. Now we are going to start a beautiful series of the objective type questions, the chapter atom. It's class 12 physics, very important chapter for solving because the less number of questions are coming, but a strong question above are coming in this examination of the Cbse NEET as well as the IIT examination. Let's begin with the first question. The electron is present in an orbit of energy state minus 1.51 electron volt. The angular momentum of the electron is 2h by pi, h by pi, 3h by 2 pi or 7h by pi. So the correct answer for this question is like J is equals to NH by 2 pi we know. Here N is equals to 3. So the correct answer is 3h by 2 pi. Let the potential energy of an hydrogen atom in the ground state be 0. Then its energy in the first excited state will be 10.2 electron volt, 13.6 electron volt, 23.8 electron volt, 27.2 electron volt. The correct answer for this question is, let's move with the solution part. So potential energy for a first excited state is minus 27.2 plus 27.2. This becomes 0 electron volt. So potential energy for the second, that is a minus 27.2 divided by 4 plus 27.2. This will becomes 20.4 electron volt. So kinetic energy is given here 13.6 electron volt, which is for the ground state. Hence, for the first excited state is 3.1 electron volt. That is, total energy is equals to potential energy for a second, means the first excited state, and the kinetic energy of a first excited state. This will be 23.8 electron volt, which is the summation of a potential energy and kinetic energy. Hence, the correct option is 3. That is 23.8 electron volt. Now next, moving the question on the product in a hydrogen atom is independent of the principal quantum number n. Pick the correct options. Vr, Vn, Er square or En. So move with the solution part. We know that Vn is directly proportional to 1 by n. So for that, here we can say that Vn. Next question we have the ratio of the kinetic energy and the potential energy of an electron in the hydrogen atom will be 1:2, -1:2, 2:1, -2:1. Let's move with the solution part. So we know that potential energy is minus 2 times of a kinetic energy. So for that, the correct option for this question is -1:2. Fifth question is the velocity of an electron in its fifth orbit. If the velocity of an electron in the second orbit of a sodium atom is, atomic number is given 11, is V, will be V 22V by 5, 5 by 2V and 2 by 5V. So the correct option for this question is to move with the solution part. So Vn is directly proportional to 1 by n. Hence from here we can say that 2 by 5V is the correct answer. Next question is the ratio of energies of its first two excited state hydrogen atom is 4, 1 by 4, 4 by 9, 9 by 4. Students, let's move with the solution part. So En is equals to minus 13.6 z square by n square. From here, as we can see in this question, here we have to ask the first two excited state. So E is directly proportional to 1 by n square, and for that, the first two excited state, that is a 9 by 4. Next question we have, let F1 be the frequency of a series, limit of the Lyman series, F2 be the frequency of the first Lyman series, and F3 be the frequency of a series in the limit of a Balmer series. So F1 minus F2 is equals to F3, F2 minus F1 is equals to F3, F3 is equals to half of F1 plus F2, and fourth is a F1 plus F2 is equals to F3. So let's move with the solution part, students. F1 relates for the N1 is equals to 1, N2 is equals to infinite, and F2 relates N1 is equals to 1, N2 is equals to 2. And F3 relates N1 is equals to 2 and N2 is equals to infinite. So for that scenario, we can say that F1 minus F2 is equals to F3. Next question. For a certain atom, there are energy levels ABC corresponding to the energies value. EA is less than EB is less than EC. Choose the correct option if lambda 1, lambda 2, lambda 3 are the wavelength of radiation corresponding with the transition from C to B, B to A and C to A respectively. So lambda 3 is equals to lambda 1 plus lambda 2, or lambda 3 is equals to lambda 1 lambda 2 by lambda 1 plus lambda 2. Third is lambda 1 plus lambda 2 plus lambda 3 is equals to 0. And the fourth one is 3 times the lambda 2 is equals to lambda 3 plus 2 times the lambda 2. Now let's move with the solution part. 1 by lambda 1 is equals to 1 by lambda 3 minus 1 by lambda 2, which is implies that 1 by lambda 3 is equals to 1 by lambda 1 plus 1 by lambda 2. So lambda 3 is equals to lambda 1 lambda 2 by lambda 1 plus lambda 2. For we can say that the correct option is option 2. Next, the limit of Balmer series is 3646. A. The wavelength of the first number of this series will be 6563 angstrom, 3646 angstrom, 7200 angstrom, or a 1000 angstrom. Solution is 1 by lambda is equals to R times 1 by N1 square minus N2, 1 by N2 square. So 1 by lambda is equals to R times 1 by 2 square minus 1 by N2 square. 1 by lambda 1 is equals to R times 1 by 4 minus 0 square, that comes R by 4. So lambda 1 by lambda 2 is R times 1 by 4 minus 1 by 9, that comes the value option 1. Next question, we have the maximum wavelength of a Lyman series is R 4 by 3R, 1 by R square, C by R, or 1 by RC. Let's move with the solution part. So 1 by lambda is equals to R Z square times 1 by N1 square minus 1 by N2 square. And N1 is equals to 1. So for that, what we can say that N2 is equals to 2. According to that, we can say the correct option is a 1, which is a 4 by 3R. Consider an electron in the nth orbit of a hydrogen atom in the Bohr's model. The circumference of the orbit can be expressed in terms of the de Broglie wavelength lambda of that electron as first 0.29259 times n lambda, second root of n lambda, 13.6 lambda, and n lambda. So let's move with the solution part, students. According to the Bohr's theory, which is equals to like angular momentum must be conserved. So which value is the mvr is equals to nh by 2 pi. From here we can say circumference is the 2 pi r, isn't it? So 2 pi r is equals to nh by mv, which is after solving we get n lambda. So the correct answer for this question is n lambda. Next question is the ionization energy of an hydrogen is 13.6 electron volt. If H is equals to 6.6 10 to the power minus 34 joule second, the value of R will be the border of 10 to the power 10 meter inverse, 10 to the power 7 meter inverse, 10 to the power 4 meter inverse, or 10 to the power minus 7 meter inverse. Let's move with the solution part, students. So E is equals to minus RCH. If we just put the value of like E, C, and H, we get the value of R, which is 10 to the power 7 meter inverse. Next question. The radius of a hydrogen atom is its ground state is 5.3 10 to the power minus 11 meter. After the collision with the electron, the ground, it is found that radius of 21.2 10 to the power minus 11 meter. What is the principal quantum number n of the final state of the atom? These are the options that n is equals to 4, n is equals to 2, n is equals to 16, n is equals to 3. So let's move with the solution part. We know that R is proportional to N square, that is Rf by Ri is equals to Nf square by Ni square. After putting all these values, we get the value of N is equals to 2. From this, we can say the correct option is 2. Next question we have the wavelength of the energy emitted when the electron comes from 4th orbital state to the 2nd orbit in the hydrogen is 20.397 centimeter. The wavelength of energy for transition in HEA plus is 5.099 centimeter inverse, 20.497 centimeter inverse, 40.994 centimeter inverse, and the last 81.988 centimeter inverse. Let's move with the solution part, students. We know that E is equals to Sc by lambda, which is proportional to Z square by N square. So lambda is directly proportional to 1 by Z square, as we can say. So lambda He plus 4, that is 20.397 by 4, which comes 5.099 centimeter. Hence, we can say that the correct option is 1. Here the students, there will be a little bit mistake. This will be actually inverse. Next question we have, in a hydrogen atom, if the differences in the energies of the electron in n is equals to 2 and n is equals to 3 orbits is E, the ionization energy of a hydrogen atom is 13.2 E, 7.2 times of E, 5.6 times of E, and 3.2 times of E. So let's move with the solution part. Energy E is equals to K times 1 by N1 square minus 1 by N2 square, where K is a constant. So N1 is equals to 2 and N2 is equals to 3. We have to just put and get the value of E in terms of a K. So 1 by 2 square minus 1 by 3 square times a K. After a little solution, E is equals to K times 5 by 36. For removing the electron from N1 is equals to 1 to N2 is equals to infinite. We just put all these values, so energy E1 is equals to K times of 1, which is equals to 36 by 5 times of E. That comes 7.2 electron. Seven 7.2 times of E, that means we can say the correct option is option 2. Next question we have, the ratio of the longest wavelength in the Lyman series of hydrogen spectra is 25 by 9, 17 by 6, 9 by 5, and 4 by 3. So little bit move with the solution part. It's a not hard question, little bit easy. So for Lyman series, as we know, 1 by lambda max is equals to R times 1 by 1 square minus 1 by 2 square, which comes 3 by 4 times of R. 1 by lambda min is equals to 1 by R times 1 by 1 square minus 1 by infinite square. So R by 1 we receive lambda max by lambda min is equals to 4 by 3. I hope you understand, students. So correct option is a 4. Next, radius of the first orbit of the electron to the hydrogen atom is 0.53 A. So that radius of the third orbit will be, here we have an option. Let's move with the solution part. The options are like this: 2.12 ampere, 4.77 ampere, that 1.06 ampere, and 1.59. So we know that Rn is proportional to the n square, so R3 by R1 is equals to 3 square by 1 square, so R3 9 times of R1. R1, the value is 0.53 for the Bohr's. Radius, that comes 4.77 of A. The correct option is 2. Last question we have, the first line in the Lyman series has a wavelength lambda. The wavelength of the first line in the Balmer series is 2 by 9 lambda, 9 by 2 lambda, 5 by 27, 27 by 5. Let's move with the solution part, student. So for the first line of our Lyman series, L1 is equals to 4 by 3R, which is the option 1. We can say equation 1. So for the first line in the Balmer series comes lambda B1 is equals to 36 by 5R, which is the equation number 2nd. So from equation first and second, what we can say that lambda B1 by lambda L1 is equals 27 by 5, or lambda B1 is equals 27 by 5. Lambda B1 is equals 27 by 5 times of A, which is option 4. So this is all much about today's class. I hope you understand, students. Revise the concept regularly till that. Take care. Thank you for watching this video.